So n input gates, this means what if there are more than 2 gates? There's n, where n is 3 or 4 or 5, etc. And we've been drawing AND gates like this, for example, A, B, and an X out of it. Because we know that in our integrated circuit, it's made of 4 AND gates, but each AND gate only has 2 inputs. So you go into a lab, for example, and you say, well, you want me to build something with 4 inputs into an AND gate. Well, what on earth do we do? Well, what you do is you simply use more gates in that chip. So let's do an example where we need a 3 input AND gate. So what we would basically do, so for a 3 input AND gate, is we would use the AND gate from our chip. So you only have a 2 input AND gate in your chip. So A and B would come into your 2 input AND gate. And I believe that was, I'm going to scroll back, I think it's called pin 1 and pin 2. Yeah, so pin 1 and pin 2, and the output comes out of pin 3. So what you're going to do is you're going to take A, B, and that's going to be literally wired to pin 1 and pin 2, and X is going to come out of pin 3 in your 7404, your quad 2 input AND gates. But now I'm asking for 3 input AND gate. So what do I do now? I need to then take that and I need to wire it to the next AND gate. So all I do is I then take that output from the first AND gate and I put another input into that AND gate called C. And now that's going to be literally, so this is the same thing. This is pin 3 is now going to get wired into pin 4. And pin 5 is going to get a new signal called signal C. And coming out of that is going to be our new X value. And X comes out of pin 6. I'm going to scroll back up and just make sure that I have all of the right pin numbers. So again, I took A and B into the first AND gate, which is pin 1 and pin 2. Out of pin 3, I took that right around and I wired it into pin 4. And I wired C into pin 5. And then I can take the output out of pin 6. So that makes sense for the configuration of my 7404 quad 2 input AND gate. So the question of what do you do even though you only have 2 pins of input, how do you make a 3 input AND gate? The answer is you use 2 AND gate chips and you take the result of one of those chips as an input to the second chip. And what you end up with here, let's do the math, because I know some of you aren't believing me that would that math actually work out? So let's do the math. Let's write that Boolean expression. What you would have is X coming out of here would equal A and B. And then what you would have going in here is C. So then coming out of here, you'd have A and B, and that would be ANDed with C. So that equals A and B and C. Because the brackets are redundant, we can also write that as A and B and C, just like this. So we can verify, yes, using 2 AND gates is the same as, so I'm going to say in pencil here, this acts just like This acts just like if I had one AND gate, X came out A, B, and C. You can draw it either way, but it's more correct to draw it as 2 AND gates because in reality, in the real world, these chips are not built with 3 AND gates. Let's do the same thing with OR gates. Let's draw a 3 input OR gate. So a 3 input OR gate would look like this. This is the OR gate that I have in my chip that's called 7432. But I know that that chip only brings A and B in, and it has output X. I believe that was coming into pin 1, pin 2. X was the output at pin 3. But I want 3 input OR gate. So now I need to use the next OR on that chip and wire it up into pin 4. Pin 5 will get a new input called C, and the output is going to be pin 6 output. So let's do the math on this one. This X coming out of the first OR gate is going to be A or B. And coming into pin 5 is going to be C. So when we look at the output, the overall output, I'm going to have A or B ORed with C. The brackets are redundant, so I can say that's A or B or C, which is a 3 input OR gate. I'm going to say that is the same as on paper. In our math, it's the same as drawing something like this, which we all understand to be a 3 input OR gate. A or B or C.